in any case, it is important to replicate VM and local disk because it enables shared nothing architecture to be used and enhances VM mobility. But however, replicating VM and local disk heavily degrades the performance of the primary VM. So this is a problem that has to be solved, I think. So our goal is developing a novel rapid VM synchronization mechanism. To achieve this, we take an approach called logging replay. This shows logging replay concept. In this case, to replicate a VM and its this shows the primary and secondary VMs, and each with its own local disk. And if we replicate VM and its local disk, the primary VM has to transfer dirty pages, device info, and I/O logs to the secondary VM. And the secondary VM replaces the disk write events using I/O logs. So I/O logs represent the disk I/O events produced by the primary VM. So the secondary VM replaces the disk I/O events, same disk I/O events. As a result, the secondary VM's disk data is the same as the primary VM's. So this approach can reduce the amount of data to replicate VM on disk. So I will now talk about VM on disk replication in detail. This shows the guest QEMU hardware and disk of the primary and secondary hosts. The gray box is in the memory, dirty pages, and the other white box. White box is non-dirty pages. The QEMU uses the memory data to execute disk write. And like the memory data, the disk data consists of dirty disk blocks, and non-dirty blocks. So in this case, to synchronize VMs and its local disk, so the primary VM has to transfer dirty pages, device info, and dirty blocks to the secondary VM. But as I said, in this case, we need a large amount of traffic to replicate both memories and disks. So to solve this problem, our approach lets the primary VM transfers I/O logs to the secondary VM instead of dirty blocks. So, and the secondary VM replaces disk write using I/O logs. So the secondary VM writes its memory to the disk. So this approach can reduce the amount of data to replicate VM and disk. So, yeah. When we executed the live migration using our approach, logging replay, after migration, we assume that the primary and secondary VM's disk data are consistent. So to achieve this, the secondary VM needs to be the same VM memory as the primary VMs when the secondary VM replaces disk write events. So the primary VMs transfer the memory data, which is used as disk write. So this is because the secondary VM can't make the same VM memory as the primary VMs. So should we always synchronize VMs when the primary VM executes disk write events? So I think the answer is no. I think we should only synchronize VMs when the primary VM executes disk write event using dirty pages. I will explain why. I will not explain why. So the disk write event uses two kinds of data, dirty pages and non-dirty pages. This shows the primary VMs execute disk write events using both dirty pages and non-dirty pages. So, in this case, if this memory data was updated after synchronization, before synchronization, so yeah, after this, we synchronize the VMs on the primary and secondary VMs. So, and next, the secondary VM replaces disk write using I/O logs. So, as a result, the secondary VM's disk data was different from the primary VMs. This is because the secondary VM got updated memory from the primary. And the secondary VM replaced disk write using updated memory data. So as a result, the disk data was different from primary VM's disk data. But on the other hand, the disk write using non-dirty pages are succeeded. So this means it is sufficient to synchronize VMs when the primary VM executes the disk write using dirty pages, I think. So implementation, we have implemented logging replay in Camali. Camali is VM synchronization mechanism we previously developed for achieving fault tolerance. But since Camali requires shared disks such as SAN, the disk will be the single point of failure. But since we implemented logging replay in Camali, it was able to become a shared nothing architecture, as shown here. Okay. So, this shows architecture of Camali with logging replay based on KVM. It has three major functions. First, the I/O logging is a function for saving the disk write events logs. And second, the sender sending the dirty pages, device info, and I/O logs to the receiver. This is a function for extending Camali on the basis of live migration. Finally, I/O replay is a function for replaying the disk write event using I/O logs. I will now talk about I/O logging and I/O replay functions in detail. I/O logging saves I/O logs at the block layer in KVM. This can be easily applied to many device models such as IDE and button block. So, we need to save the following information to replay the disk I/O events. So first, we need to save the device name to get block driver state structure. And second, we need to save the memory page address to get disk write data and the memory data. The sender has transferred memory data to the receiver already. And finally, we need to save the number and location of disk sectors to write data. Okay. I'll replay makes a request for the I/O event to the block layer. And disk event, when disk event has committed, the callback function is invoked. Generally, each device, such as ID, button block, each device's callback function is invoked. But in this case, only IO replace callback function is invoked. This is because if each device is callback function is invoked, the device info, the device state will be changed, updated. But the sender already has transferred the device state to the receiver. So we should not change the device state in this case. So IO replay executes at the block layer completely. So the device state is not updated in this layer. Okay. Yeah. I'll show you the effectiveness of our logging replay by presenting the results for benchmarks. We measured two experiment items. One is the traffic needed to synchronize VMs on disks. And the other is the performance of the primary VM using IOZone. Yeah. And we have implemented two techniques in Camali. These techniques are logging, replay, and dirty block copy. A dirty block copy is simply transferring dirty blocks to the secondary VM. Dirty block copy and block migration, KVM block migration, are essentially the same. Okay. Yeah. The experimental environment is as shown here. Okay. This shows the traffic per synchronization. The left bar graph shows Camali with logging replay, and the right one is Camali with dirty block copy. As you can see, the logging replay reduces the traffic by 50%. So this green box is the traffic of low disk data, dirty blocks. So and this green box, can you see it? This green box is the traffic of IO logs, and the others are VM, the traffic of the VM, device info and device dirty pages. So logging replay reduces the traffic needed to synchronize only disks by 99%. This reduction is necessary because the IO logs is much smaller. The size of IO logs is much smaller than that of dirty blocks. Okay. And this shows the traffic of synchronized network, and the x-axis is time, and the y-axis is traffic. Basically, the logging replay line, this blue line, is under the dirty block copy line. Actually, logging replayed average traffic is only half the traffic of dirty block copy line, dirty block copy. So, but both of them consumes up to 700 megabits per second at peak time. This is the feature of the event-driven synchronization in Camali. Since Camali starts synchronization when the disk write or network output occurs. So sometimes it consumes a large amount of traffic in this case. Okay. Yeah. This shows the primary VM's file I/O throughput for both bandwidths. As you can see, logging replay was good performance in both cases, especially at low bandwidths. This is the effect of reducing the amount of data needed for synchronization VMs and disks. Okay. In summary, we are developing a rapid VM synchronization mechanism, and we have implemented logging replay in Camali, and measurements show that we reduced the traffic per synchronization by 50%, and we increased file IO throughput by 160%. In future work, we will address the problem of disk failure propagation. By this I mean, if the primary VM's disk crashes when the primary VM reads the disk, the disk read errors propagate to the secondary VM. So this is a problem that has to be solved. But in other failure cases, we can verify this consistency. We will implement memory replication shown with logging replay. This will enable secondary VM to replay disk read events produced by the primary VM. So we will implement block migration. We will implement block migration with logging replay to improve the performance of the block migration. Okay, thank you.